Welcome to the debate. Today we're staring into the abyss of the absolute. We're asking a question that defines not just physics, but really the very nature of existence. Is reality singular or is it infinite?
Right. When you make a choice, does the universe literally split to accommodate the road not taken? Or is that idea, the many worlds interpretation, just a spectacular misunderstanding of the mathematics?
Exactly. And to guide us, we're dissecting a pretty dense, provocative set of source materials titled One Invariant Structure. This text, it really throws down the gauntlet. It argues that many worlds, or MWI, isn't a scientific breakthrough at all. It claims it's an act of ontological inflation, basically that we've mistaken our map for the territory.
And that is where I'm going to have to stop you right out of the gate. Because the position I'll be representing today, the standard quantum picture, is that MWI isn't inflation at all. It is simply what happens when you have the courage to take the Schrödinger equation literally. There's no magic, there's no mysterious collapse mechanism, just the math evolving. If the math say the universe branches, then, well, the universe branches.
I expect nothing less from the orthodoxy. But there is a massive twist in today's material. We aren't just debating the multiverse. This invariant structure thesis argues that if we take geometry seriously enough to kill the multiverse, we also have to completely rethink energy. We're going to discuss a highly controversial proposal that geometric topology modifies Einstein's famous E=mc², introducing a new factor called kaita.
Which is, frankly, a very dangerous claim. You are effectively suggesting an edit to special relativity. So your source material wants to delete the multiverse and modify rest energy in one go. We definitely have our work cut out for us.
We certainly do. But let's start with the multiverse. The source material opens with this classic thought experiment. You flip a coin, it lands heads. You see heads.
Right. Just standard classical experience.
Right. But in the quantum picture, before the flip, that coin was in a superposition, a mix of probability amplitudes for heads and tails. The MWI proponent looks at the math and says, well, the equation describes both outcomes. It never says the tails part was actually deleted. Therefore, the tails outcome must still exist.
Precisely. And this is crucial for the listeners to understand. In standard quantum mechanics, the math is unitary. That means information is never lost. The wave function evolves smoothly. It doesn't snap, it doesn't break. So if the equation says heads plus tails, and you only see heads, the tails part didn't vanish into nothingness. It just decohered from you. It's in a branch of reality you can no longer interact with. It is by far the most parsimonious, logical reading of the equation.
And this is exactly where the invariant structure argument really drives a wedge in. The central thesis here is that MWI violates the core methodology of modern physics, and that methodology is invariance.
Okay, invariance is a sacred concept in physics, sure, but you need to define the stakes here. How exactly does many worlds violate it?
Well, think back to special relativity. When Einstein realized that different observers disagree on measurements, like I see a second tick by, you see 2 seconds, or I measure a meter, you measure half a meter, he didn't conclude that there are multiple times or multiple spaces. He didn't say, well, both times are real in completely separate universes.
No, he looked for the underlying structure that unified them.
Exactly. He looked for what did not change. He found the space-time interval. The variation in our measurements revealed one invariant geometric structure. The source material argues we are making the pre-Einstein mistake with quantum mechanics. We see variation in the wave function, different branches, different outcomes, and we just assume multiple worlds. But the text argues that these branches are just artifacts of how we describe the system. Variation reveals invariance, not multiplication.
I see the parallel, I do, but I think it misses the actual mechanics of quantum theory. When we talk about branches, we aren't talking about subjective viewpoints. We are talking about orthogonality. When the coin lands, the heads version of me and the tails version of me become mathematically orthogonal. They are at right angles in the vector space that cannot communicate. That separation is real regardless of your coordinate system.
But is it real in a fundamental sense? The source calls this the emergence defense, and honestly, it attacks it ruthlessly.
Look, it's not a defense, it's an explanation. We argue that worlds are emergent structures, kind of like hurricanes, or tables. A table isn't a fundamental object. It's a fuzzy collection of atoms. But it's still real. We don't need a table to be defined down to the Planck scale just to put a coffee cup on it. Similarly, we don't need worlds to be fundamentally exact. They just need to be robust enough to hold a cohesive history.
But here is the problem with that. And the source is very specific on this. Real emergent things, like your table, survive symmetry transformations. If I rotate my coordinate system 45 degrees, the table is still there. It doesn't dissolve. But branches in MWI are different. The source points out that the branch structure depends entirely on the foliation of spacetime, literally how you slice time.
Okay, but that's a highly technical objection regarding relativistic covariance.
It's an ontological objection. The maxim in the text is, equivalent descriptions cannot license incompatible ontologies. If the math says description A, which has two worlds, and description B, which has one world, are mathematically equivalent, then worlds cannot be part of the fundamental furniture of reality. You can't have the number of universes depend on how a physicist chooses to write down the equation.
But this completely ignores the phenomenon of robustness. Yes, the boundaries are fuzzy. Yes, if you change the coarse graining, the branch count might shift slightly. But the core narrative, the history where the dinosaur died versus the one where it didn't, is robust. The decoherence creates a stability that you can't just wave away with a coordinate transformation.
Is it robust, though, or is it just a category error? The text argues MWI confuses orthogonality in a vector space, which is just a mathematical list of numbers, with separation in spacetime, which is geometry. Just because two mathematical terms don't interfere doesn't mean they generate a new, independent spacetime manifold.
Now we are getting into the space-time dilemma.
Exactly. This is horn one of the argument. If spacetime is fundamental, you can't just wish new spacetimes into existence because your vector happens to have two components. That is magical thinking. You need a mechanism to generate new geometry, and the Schrödinger equation absolutely does not provide one.
Right. But what if space-time isn't fundamental? That's the leading edge of physics right now. What if space-time emerges from entanglement?
And that's horn two. If spacetime emerges from entanglement using something like tensor networks, current research shows it produces one geometry. There is no derivation anywhere in physics that shows orthogonal quantum components generating multiple independent spacetime manifolds. MWI is writing checks that quantum gravity hasn't cashed.
I think you're being entirely too literal about manifolds here. When we say worlds, we mean causal domains. We mean that the version of me that saw heads can no longer causally affect the version that saw tails.
But a causal domain requires a geometry. Otherwise, it's just the list of numbers in a computer. And this leads to the biggest problem the source identifies, which is probability. This is the foreclosure problem.
We prefer to say every possible outcome happens.
But think about what probability actually means. Probability requires foreclosure. It requires that some things do not happen. If I say there's a 50% chance of rain, it means there is a 50% chance it won't rain. In MWI, it rains in one branch and stays dry in the other. Both happen. So probability loses its entire meaning. It just becomes a tautology. Everything that can happen does happen.
We've spent 30 years working on this exact issue. We treat probability as self-location. The universe is deterministic, yes, but you, the observer, don't know where you are. You know it rains in some branches and not others, but you don't know which branch you are in. The probability is just a measure of your ignorance, not the universe's randomness.
But that circularity is exactly what the text attacks. To ask which branch am I in, the branches have to be objective containers that exist before you ask the question. But we just established that branches depend on your descriptive choices. You can't have self-location uncertainty in a landscape that isn't objectively mapped. The source puts it brutally. You cannot distribute credence over a space whose topology is not determined by the theorem. No. The source suggests one invariant structure. The universe is one object, the wave function, differentiating internally. It doesn't multiply. It's like a diamond with infinite facets. We are looking at one facet. That doesn't mean the other facets are separate diamonds floating around. It means the structure is complex and relational.
It's a beautiful image. One invariant structure, internal relational differentiation. It saves the math, but it definitely kills the multiverse.
It kills the inflation, it keeps the reality. It implies that what we call possibility isn't a separate world, it's just the geometry of the single structure we're in.
All right, well, I'm willing to suspend judgment on the multiverse for a moment. But the source material takes a hard left turn here. It tries to apply this same logic, this obsession with invariance and geometry, to energy. And this is where I get incredibly nervous.
You're referring to the volumetric rest energy section.
Yes, the text proposes a modification to the holiest equation in history, E equals mc squared. It introduces a factor, chi t. The formula becomes E equals mc squared chi t.
Correct. Chi t stands for the topological characteristic of the field.
Now listen. E equals mc squared is derived from the symmetries of space-time itself. If you mess with that, you are messing with Lorentz invariance. You're implying that the energy of an electron depends on where it is or what shape it's in. That breaks the universality of physics.
That is the standard knee-jerk reaction. But the advocate for this theory would say you are making the exact same mistake as the MWI proponents. You are ignoring the boundary conditions.
Okay, explain what you mean by boundary conditions in this specific context.
The argument is that Einstein's formula, E equals mc squared, is just the limit case for free space. It assumes a vacuum that is infinite, flat, and unbounded.
Which is a perfectly reasonable approximation for almost everything in the universe.
For most things, yes, but we know, for a fact, experimentally proved, that if you put boundaries in a vacuum, you change the energy state. This is the Casimir effect.
Sure, I know the Casimir effect. You take two uncharged metal plates, put them very close together in a vacuum. The energy density between them actually drops because you exclude certain wavelengths of the vacuum fluctuations. The plates get pushed together. That's just standard quantum field theory.
Exactly. The source summarizes this beautifully. Constraint writes the choir.
The choir?
The spectrum of allowed modes. Imagine a choir singing in a massive cathedral versus a choir singing in a tiny broom closet. In the cathedral, which is free space, the choir can sing any note, from the deepest bass to the highest soprano. The spectrum is continuous. But in the broom closet, a bounded geometry, the bass notes simply don't fit. The acoustics physically restrict which notes can exist.
Okay, I follow the metaphor. The geometry restricts the vacuum modes.
And if the spectrum, the choir, changes, the energy density changes. That is what the Casimir effect is. The source simply formalizes this for rest energy. Chi t, or the topology factor, is the ratio of the spectral density in the bounded space to the spectral density in free space.
So wait, chi t isn't a new fundamental constant of nature?
No, not at all. It's a geometric response function. It's usually 1.0000 out to many decimal places. But in highly constrained geometries, like a tight toroidal cavity or a nanostructure, chi t deviates from 1.
So let me get this straight. The argument is, rest mass, m, is energy. Energy is stored in the field. The field configuration depends on the geometry. Therefore, the effective rest energy of a particle depends on the geometry it inhabits.
Precisely. E equals mc squared chi t. The text uses a great analogy involving pressure. At sea level, water boils at 100 degrees Celsius. On Mount Everest, it boils at 70 degrees.
Because the pressure constraint is different.
Right. The constraint changes the thermodynamic threshold. The author argues that geometric topology acts like pressure for the vacuum. It changes the spectral pressure, which changes the energy expression.
Look, it's a seductive argument because it builds on established physics. We know Casimir is real. We know boundaries change mode densities. But to say this modifies the rest energy of a particle, that implies if I put an electron inside a nanocavity, its mass energy effectively changes. That feels like a direct violation of the equivalence principle.
The effective energy changes, yes. But the source is very careful to say this isn't a fifth force. It's an accounting of the energy stored in the field coupling to the geometry. It's saying that E equals mc squared assumes linear propagation, but if the field is self-interacting in a closed loop, the energy accounting must include the topology of that loop.
But if this were true, why haven't we seen it? We smash particles together at the Large Hadron Collider every single day. We know their masses to extreme precision. If there was a cheetah factor wobbling around, we definitely would have noticed.
But think about where we smash them.
In a vacuum pipe?
In a high vacuum beam pipe specifically designed to be as close to free space as possible. The source argues that particle accelerators operate in the exact regime where Chi-T is approximately 1. They are explicitly built to test the free space limit.
You are measuring the choir in the cathedral.
That is a really fair point. We deliberately remove boundaries to get clean data.
The prediction here is that you wouldn't see this in a collider. You would see it in high-Q toroidal cavities or nanoscale Casimir geometries, places where the geometry is tight, closed, and resonant.
The text mentions volumetric confinement, the idea that if you close the field lines in a torus, you fundamentally change the circulation of the energy. Yes. It contrasts linear propagation, the squared C, with volumetric circulation. The claim is that energy has a geometric shape. If you force that shape into a loop, the value has to change. It's risky. It walks a really fine line between brilliance and complete heresy. But I have to admit, it's structurally consistent. If you accept that vacuum energy is real, which we do, and that geometry changes it, which we also do, then there must be a geometric factor in the energy equation. I just really want to see the scattering calculation.
And that brings us right back to the central theme of this entire file: invariance.
How so? Tie it together for me.
In the many worlds critique, the argument was, don't multiply worlds, look for the invariant structure, which is the wave function. In the energy critique, the argument is, don't assume the energy value is a magical constant number. Look for the invariant relationship between geometry and spectrum.
Variation reveals invariance.
Exactly. The energy varies with geometry because the underlying invariant law is that spectrum determines energy. If you ignore the geometry, you miss the invariant law and just memorize a special case, E=mc².
So the argument's worldview is that the universe is one single, connected, geometric whole. It doesn't branch into infinite copies. And its properties, like energy, are not abstract numbers floating in a void, but are determined by the shape of the structure itself.
One invariant structure: internal relational differentiation.
It's a very deterministic, almost Spinozian view of the universe. It lacks the wild, infinite potential of the multiverse where everything happens somewhere.
But it gains coherence. The source ends with a reflection on that coin flip we started with.
Right, the coin flip.
In Indo-UI, the coin lands heads and tails. You are a splitter. You create new universes with every breath. In this view, the coin landing heads didn't create a world where it landed tails. It simply revealed one path through the geometry.
The text says, what we call movement through time may be nothing more than the sequential reading of a text that was always already complete.
That gives me chills every time I read it. We are threads reading the text. We aren't writing it, and we certainly aren't photocopying it.
I'm still on the side of orthodoxy at heart. I think the math of quantum mechanics is so successful that I'm hesitant to restrict it just because the ontology feels inflated. And on the energy side, until I see a lab experiment confirm Chi-T, I'm sticking with Einstein and the raw. But I will say, I'll never look at a vacuum chamber the same way again.
And that is the proper scientific attitude: skepticism. But the invariant challenge is definitely on the table. It asks us to stop settling for good enough interpretations and really look for the deep structure.
Indeed, it forces you to ask, are we inventing complexity or discovering simplicity?
A fantastic question for another day. Thank you for joining us on this deep dive into the architecture of reality.
Always a pleasure to argue about the nature of existence.
And thank you to our listeners. Whether you are in a single universe or just one branch of many, we appreciate you tuning in to the debate.
You know that specific frustration when you're trying to understand something massive, really massive, like the nature of time itself or where human consciousness actually comes from, or even what energy is at a fundamental level. And then you go and you read the standard scientific explanation.
Right. Yeah, you get the textbook definition.
Exactly. You get the textbook definition, you get the mechanics, you get the how of it all, but then you're left with this nagging, almost itch-like sensation that the explanation stopped about 3 inches too short.
Oh, absolutely. It's the difference between knowing how the gears of a clock turn and knowing what time actually is. We get the mechanics, but we completely miss the meaning.
That is exactly it. We get the how, but the what is it really remains this elusive ghost in the machine. And usually we just shrug and say, well, I guess I'm just not smart enough to get the rest of it. But today, for this deep dive, we are taking a completely different approach. We're going after the ghost.
We are. And we're doing it by stripping away those standard, comfortable answers to look at 3 absolutely massive arguments. I mean, 3 distinct papers that fundamentally challenge the way we structure reality itself.
And structure really is the word of the day here, isn't it?
It is, yeah. If I had to put a theme on today's deep dive, it would be structure, constraint, and invariance. We are looking at reality not as a messy, random accident, and certainly not as a branching multiverse where everything just happens,
Right.
but as a single, tightly woven invariant structure.
So we have a stack of sources today that are frankly mind-bending for you all listening. Let me just lay them out so everyone knows what we're getting into. First, we've got a philosophical physics treatise titled One Invariant Structure. And this thing basically takes a sledgehammer to the many worlds interpretation of quantum mechanics.
Yeah, and that is going to upset a lot of sci-fi fans, and frankly, a lot of very smart physicists too.
Oh, definitely. It's a bold stance. Then we pivot over to biology with an evolutionary critique titled The Discontinuity Argument. This one questions the standard materialist explanation for human culture. It basically asked why, if evolution is continuous, humans are such weirdos compared to everything else in nature.
Right, it completely challenges the idea that we are just, smarter apes.
Yeah. And finally, we have a radical physics proposal regarding something called volumetric rest energy, which argues that geometry actually determines energy. So E equals mc squared might not be the whole story.
It's a really heavy stack of reading.
It is.
But the mission here is simple. We want to show you that limitations, boundaries, rules are actually what create reality. It's not about infinite possibility at all. It's about the structure that limits possibility to create actual meaning.
I love that. So let's jump right into the deep end. Section 1, the case against the multiverse.
Let's do it.
I think most of us, thanks to Marvel movies and, pop science on YouTube, we have this intuitive idea of the multiverse. The idea is that every time I make a choice, let's say I choose coffee instead of tea, the universe splits.
Right, the branching timeline.
Exactly. There's a version of me drinking tea in a parallel world and a version of me drinking coffee here. And it feels strangely comforting. Like all possibilities exist somewhere out there.
Oh, it's very comforting. It means you never really make a mistake, because in another world, you did the right thing. You made the optimal choice. But this source, one invariant structure, it says, stop. That is not just wrong. It is a fundamental category error about what time actually is.
A category error, which is a really polite academic way of saying you're thinking about this completely backwards.
Precisely. To understand why it's backwards, we have to look at how we intuitively view time. We usually think of time as a container, like a long corridor.
Right, moving through it.
Exactly. The past is a room we've already left, the future is a room we haven't entered yet, and the present is just where we happen to be standing right now.
It feels very natural to think that way. I walk through the hallway of time, I am the physical object, and time is just the empty space that I move through.
Sure, but the source opens with a brilliant thought experiment to show exactly why this container thinking leads to massive paradoxes.
Yeah.
Imagine you flip a coin.
Yeah.
It lands heads. You look at it, you remember it landing heads.
Okay, I'm with you.
Now, imagine purely as a structural question, not a magic time travel movie,
Right.
what it would literally mean to return to the moment right before the flip. You stand opposite your past self. Past you doesn't know the outcome yet. Present you does. You reach out and touch past you.
And usually this is where pop culture says the universe explodes. You get a paradox. Two objects trying to occupy the same space. The classic grandfather paradox.
Exactly. But the source asks, why doesn't it explode? If you stop thinking of time as a container, there's no paradox at all. You aren't two separate objects trying to occupy the same room. You are two world lines, two threads of causality intersecting in a four-dimensional geometry.
Wait, let's unpack world lines for a second, because I've heard the term thrown around, but I want to make sure we're defining it clearly for everyone listening.
Good call. Think of a world line as your entire physical path through space-time. It's like a thread frozen in a block of ice. The source argues that now isn't a universal place that we all stand in together. Einstein's relativity taught us that a long time ago. Space-time is the actual object. It's one solid block of geometry.
Okay.
And observers just see different slices of it depending on their speed and gravity. So if you hypothetically went back, you're just a thread looping back to intersect an earlier part of your own thread. It's a geometry. It's not a physical collision of containers.
So the paradox only really exists if we think moments are like sovereign locations, like separate boxes that we hop between. If it's all one woven fabric, intersections are they're just knots.
Precisely. They're just knots in the fabric. And this sets up what the paper calls the Einstein move, which is the core logical tool the source uses to dismantle the entire multiverse concept.
The Einstein move. I love a good maneuver. But before we get to the move, I do have to play devil's advocate here, because I want to be fair to the other side.
Sure.
The Many Worlds Interpretation, or MWI, it isn't just a Marvel movie plot. It was developed by Hugh Everett. It's taken incredibly seriously by some of the smartest mathematicians and physicists on Earth right now. Are we really saying they just made a freshman logic error? And I want to remind everyone listening, we are just presenting the argument from the source material here. We're not taking sides in the physics community.
Right. That's a very fair point to make. And the source addresses this directly. They didn't make a math error. The math in quantum mechanics is incredibly robust. They made an ontological error. They basically mistook the map for the territory.
Okay, explain that. How do they confuse the map and the territory?
So, back when Einstein was figuring out special relativity, he noticed a major problem. Observers moving at different speeds disagree on basic measurements. You might say a train is 100 meters long, but because of my speed relative to the train, I might measure it as 90 meters.
Right. Time dilation, length contraction, all that fun stuff.
Exactly. And the basic human intuition would be to say, well, I guess we live in different worlds. You have your physical space where the train is 100 meters, and I have a separate space where it's 90.
Which sounds exactly like a multiverse.
It does. That's what philosophers call ontological inflation. You multiply realities to explain the variation you're seeing. There's a 100-meter world and a 90-meter world. But Einstein went the exact opposite direction.
He didn't invent a new world.
No, he asked, what is invariant? What actually stays the same, despite our disagreement? And he found the space-time interval. He realized we aren't in different worlds at all. We are looking at the exact same invariant object from different geometric angles. The variation actually reveals the invariance.
Okay, so the variation, the disagreement between you and me, is literally just perspective. The object itself is solid and unchanging. But how does this Einstein move actually kill the many worlds interpretation?
Because MWI does the exact opposite of what Einstein did. In quantum mechanics, when you measure something, a particle's spin, for instance, the math shows these branches, it looks like different possible outcomes. The mathematical wave function spreads out. The proponents of many worlds see these branches in the math and they say, look, multiple worlds. They are all physically real.
So they're inflating the ontology. They see a variation in the mathematical formula and just assume a multiplication of the actual physical universe.
Exactly. They assume math equals reality in a one-to-one literal sense. And the source uses a completely devastating analogy here to explain why this is a mistake. The time zone analogy.
Oh, this was my favorite part of the paper. Because it really makes you feel slightly silly, forever believing in a literal multiverse. Walk us through it.
It's so elegantly simple. We divide the Earth into 24 time zones using a meridian grid, right? So when it's noon in London, it's 7 a.m. in New York. We use completely different numbers to describe the time at those locations.
Right, but it's the same moment in objective reality.
Exactly. Does using 24 different time designations mean there are 24 physical Earths?
Obviously not. It's one Earth, measured differently depending on where you stand.
Right. The grid is just a way of measuring and indexing the Earth. The branches in quantum mechanics are just like those time zones. They're coordinate systems. They're mathematical indexes we use to describe the universal wave function. But MWI makes the critical mistake of thinking the index is the territory. They think because the math has, separate slices, there must be separate physical universes.
That is, honestly, it's kind of embarrassing for them when you put it in those terms. They are looking at the lines of longitude on a globe and thinking they're actual physical walls in the ocean.
It's a profound conceptual error. The source argues forcefully that the universe is a closed structure. To exist fundamentally means to participate in the causal fabric of reality. But MWI claims these other branches are equally real, yet completely causally disconnected from us.
Which is a massive contradiction, isn't it?
But totally. If they are truly disconnected, they don't exist relative to us in any meaningful way. If they're connected, well then they're just interacting parts of one single world. You really can't have it both ways.
Okay, hold on. I need to push back here again. because you're saying probability dies in the many worlds interpretation. But MWI proponents, they use probability all the time in their papers. They say, there's a 50% chance I'll see the coin land heads. Why is this source arguing that they aren't conceptually allowed to say that?
It's a great question, and it really gets to the heart of what physicists call the Born rule problem.
The Born rule, right.
Yeah. Think about it this way. In a standard single universe, probability is entirely based on ignorance. I flip a coin. I don't know the result yet. Therefore, I assign a probability to my ignorance.
Right. Me saying I don't know equals a 50-50 chance.
But in many worlds, there is zero ignorance from a God's eye view. The theory explicitly states that the universe must branch into all possible outcomes. The physics guarantees, with 100% absolute certainty, that a heads version of you exists and a tails version of you exists.
Okay, so if both definitely physically exist in the multiverse...
Then what exactly does the number 50% refer to? You can't logically say there's a 50% chance you're the heads version. Both versions are equally real. Both versions feel completely like they are you. Both versions have your exact memories leading up to the flip.
Wow.
So the source argues that MWI proponents are basically smuggling the concept of chance back into a theory that is completely explicitly deterministic.
They're trying to have their cake and eat it too. They want the deterministic math of the branching because it solves some quantum equations beautifully. But they also want to keep the I don't know what's going to happen feeling of standard probability because that's how we actually experience life.
Exactly. And the source uses a pretty brutal term for this. They call it conceptually incoherent. They argue that if you actually take MWI seriously as a philosophy, you literally can't make rational decisions anymore.
Wait, why not?
Well, think about crossing a busy street. Why look both ways? In one branch of the multiverse, you get hit by a car. In another, you don't. If the universe splits every time and you care about all your future selves equally, traditional decision theory completely collapses.
That is, honestly, that's existential dread-inducing.
Yeah.
So the probability crisis isn't just some abstract math problem on a chalkboard. It breaks the fundamental logic of how we live and act in the world.
It really does. And the source wraps this whole section up with something they call the space-time dilemma, which is essentially the technical knockout punch. It basically says to the MWI crowd, look, you have two choices. Horn 1, space-time is fundamental. Horn 2, space-time is emergent.
Okay, walk me through the horns. Let's start with horn 1. Space-time is fundamental.
Right. If space-time is fundamental, meaning it's a real basic geometric object like a stage that events happen on, then a branch in the math, which is literally just an orthogonal vector in Hilbert space, doesn't magically become a physical universe with its own gravity and light cones.
That's the category error again.
Exactly. A vector in an abstract math space is not a physical planet. You can't just wish a mathematical line into a physical mountain range.
Okay, I follow that. And horn 2. What if space-time is emergent? Because I know that's where a lot of modern theoretical physics is heading right now.
It is. The idea that space-time emerges from deeper quantum entanglement, like a hologram. But the problem for MWI is that all the specific models we have for this, like tensor networks or holographic duality, they show space-time emerging as one single connected geometry, not billions of separate disconnected bubbles.
Ah, I see.
So either way you slice it, the source concludes, the universe simply doesn't branch. It differentiates internally. It is one invariant structure.
One invariant structure. It feels much more solid, doesn't it? Less like a chaotic froth of infinite, meaningless possibilities, and more like a diamond, like a single, multifaceted jewel.
That's a really beautiful image for it, and it suggests that we aren't just haphazardly hopping between realities every time we make a choice. We're distinct threads woven into this one single, solid thing.
Which perfectly brings us to the next big question of the deep dive. If the universe is this single, structured, coherent thing, how exactly do we humans fit into it? Because the second source, the discontinuity argument, suggests that humans are, well, we're a bit of a glitch in the matrix, aren't we?
A glitch, or maybe a completely new layer of code. This source moves us entirely away from cosmology and right into biology and evolution. And it starts with a law that I think most people don't even realize exists in biology, the law of behavioral continuity.
This is basically the idea that evolution is incredibly lazy, right? It just constantly reuses old code.
Conservative is the polite academic word for it. But yes, lazy works too. The source points out that across the entire living world, evolution preserves behavioral templates, even when the physical form of the animal changes drastically.
The examples in the paper here were absolutely great. Let's talk about the wolf-to-dog pipeline.
The classic example. We have selectively bred dogs for roughly 15,000 years. We turned wild wolves into tiny chihuahuas and massive Great Danes. Physically, structurally, they are almost unrecognizable as wolves.
I mean, a chihuahua is basically a physical mutant, let's be honest.
Right. But inside that tiny brain, it's still running Wolf 1.0 software.
That's so true.
It circles the carpet before it goes to sleep, just like a wolf tramping down grass. It inherently understands pack hierarchy. It marks its territory. The physical hardware completely changed, but the behavioral software is incredibly ancient and untouched.
Okay, I buy that. And we have that with cats too, right? The paper mentioned house cats and lions.
Exactly. A tiny tabby cat stalking a laser pointer in your living room is executing the exact same behavioral template as a lion stalking a gazelle on the savannah. The software is conserved. Even with whales, they went back to the ocean 50 million years ago. They look like fish, but they act like mammals. They nurse their young, they breathe air, they form complex social pods.
So the outside changes to adapt to the environment, but the internal operating system stays remarkably consistent. And we usually assume the exact same thing is true for us humans. We just assume we're chimpanzees 2.0. We have better hardware, we have less hair, we walk upright, we have bigger brains, but fundamentally we're running ape software.
And that is the absolute standard materialist view of human evolution. But this source, the discontinuity argument, completely slams on the brakes. It says you really need to look at the structure of human interaction versus ape interaction. They aren't just different in degree. They're fundamentally different in kind.
Okay, I need a concrete example here because, I've seen nature documentaries where chimps mourn their dead. I've seen them use simple tools to get food. That all feels pretty human to me.
It feels human on the surface, but look closer at the structure of the action. A chimp uses a stick to pull ants out of a log. That is absolutely tool use. But does that chimp create a symbolic blueprint of the stick to show other chimps in the next valley how to manufacture it? Does the chimp create a Department of Stick regulation to manage who gets to use the sticks and when?
I'm going to confidently guess no on that one.
The profound difference is what the source calls externalized institutional memory. Apes learn entirely by direct imitation in the present moment. Monkey see, monkey do. But humans offload their software into the environment. We write binding laws. We build massive libraries. We create what the paper calls normative systems.
Normative systems, meaning rules about how things ought to be, not just how they are.
Exactly. We create rules about things that don't even physically exist, like the concept of justice, or human rights, or a corporation.
I see the core distinction now. You can't point to a human right in the physical world. It's not a banana. It's not a stick. It's essentially a shared hallucination that we all just mutually agree to treat as if it were a physical reality.
Shared hallucination is very close to how some anthropologists describe it, but this source prefers the term symbolic normative structure. And here's the real kicker of the argument. There is no gradual, step-by-step evolutionary path from I want that banana right now to we hold these truths to be self-evident.
But wait, let me jump in with the standard counter-argument here. And again, just representing the other side for our listeners. Most biologists would just say it's an issue of complexity. They say, well, crows are smart, dolphins are really smart, humans are just way more smart. Why can't it just be a sliding scale of intelligence, just turning up the dial?
The source addresses this exact pushback. They call it the gradualism defense. And their refutation is pretty sharp. They say a crow solving a complex multi-step puzzle to get a piece of meat is still operating entirely in the direct signal mode.
Direct signal mode?
Yes. It sees a physical problem right in front of it, and it solves it. It does not create a symbolic, abstract representation of the problem to discuss with a council of other crows next Tuesday.
Right.
Crows definitely don't have town hall meetings about the future of puzzle-solving infrastructure.
Exactly. Humans operate in what the paper calls a decoupled mode. We talk endlessly about things that are not physically present. We talk about the far future, the distant past, the completely hypothetical. And doing that requires a totally different operating system, not just a faster biological processor.
So if the wolf template runs on dogs and the ape template runs on chimps, what template is running on us?
Yeah.
Because it's clearly not just the ape template with a few upgrades.
That is the million-dollar question. The source suggests this massive gap indicates an additional organizing layer in our reality. Now, to be clear, they aren't necessarily saying it's magic or alien intervention, but they are saying there is a structural principle at work, a design, understood as an intrinsic lawful structure in the universe that standard materialist biology simply hasn't accounted for yet. It's really interesting to stack this biology argument against the physics stuff from the first section, because in the first section, We saw the universe as this rigid, invariant structure. No branching, just one solid thing. And now, within that structure, we see this sudden vertical leap in complexity when it comes to humans, almost like we somehow accessed a higher level of the geometry.
That's a fantastic way to synthesize it. Just as the many worlds proponent tries to endlessly inflate the physical universe to explain weird quantum math, the standard evolutionist tries to inflate gradualism to explain the sudden emergence of the human mind.
They're both stretching old theories to cover new anomalies.
Precisely. Both of our sources are basically shouting, stop inflating, look at the underlying structure. There is something fundamentally unique and structural happening here that you are ignoring.
Okay, so we've looked at the structure of time, and we've explored the structure of the human mind. Now we have to go down to the absolute basement, the foundation of everything, the structure of energy itself.
This is the volumetric rest energy proposal. And honestly, out of all three papers today, this is the one that really forces you to completely rewrite your mental model of the physical world.
I mean, everyone knows E equals mc squared. Even if you hate math, it's the one equation everyone knows. Mass equals energy. It's printed on coffee mugs and T-shirts everywhere.
Right, and the standard accepted view in physics is that this is a universal, fundamental constant. It doesn't matter where you are in the universe, who you are, or what you're doing. Mass is energy. End of story. But this third source asks a really provocative question. Is it? Is it really universal?
The source essentially argues that E equals mc squared is actually just a special case. It's merely what happens in what they call free space.
Right. Free space meaning an environment where there are absolutely no walls, no boundaries, no constraints of any kind.
Exactly. And the new hypothesis here is that energy itself is actually a consequence of constraint. The proposed new formula they offer is E equals mc squared times chi t.
Chi T. Now that sounds like a trendy new sci-fi energy drink. What exactly is Chi T?
So chi t is a topology factor. It's a geometry factor. It basically says, mathematically, that the total energy of a system heavily depends on the actual physical shape of the space it's confined in.
The source uses a really brilliant analogy about boiling water that honestly helped me finally grasp this. The atmosphere analogy. Let's walk through that.
Yes, the atmosphere analogy is perfect. Think about boiling a pot of water. If you are standing at sea level, water boils at 100 degrees Celsius. We all learned that in grade school. But if you take that same pot of water and go way up to the top of Mount Everest, where the atmospheric pressure is much lower, meaning the physical constraint of the atmosphere pushing down on the water is less. The water actually boils at around 70 degrees Celsius.
But the physical water didn't change at all. The H2O molecules are exactly the same on the mountain as they are on the beach.
Correct. The water is identical. What changed was the constraint. The atmospheric pressure constraint altered the underlying thermodynamic spectrum of the water, which directly changed the energy threshold required for boiling.
Okay, that makes sense on a macro, everyday level. But I'm still a bit stuck on applying this to the actual fundamental formula, E equals mc squared chi t. We've established that energy behavior depends on constraint, like the boiling water on Everest. But how in the world does this apply to something like a vacuum? Because vacuum is defined as being empty. There's no atmosphere to provide constraint.
This is where the physics gets completely wild. To understand this, we have to talk about something called the Casimir effect, which is not science fiction. It is a real laboratory-proven phenomenon in quantum physics.
I've vaguely heard of the Casimir effect. It has something to do with the force between two metal plates, right?
Right. So you take two uncharged metal plates, you place them in a total perfect vacuum, and you push them incredibly close together, microbes apart. And inexplicably, they attract. They actively pull together. Now, why does that happen? Because there's no gravity strong enough, and they aren't magnetic. There is literally nothing pushing them.
I have no idea. Is it microgravity?
No, it's too weak for that. The real mechanism is actually the exclusion of waves.
Exclusion of waves. Unpack that for me.
Okay, so quantum mechanics tells us that a vacuum isn't actually empty. It's not a void. It's more like a frothing, chaotic ocean of electromagnetic waves. Virtual particles just constantly popping in and out of existence. And these waves all have different sizes or wavelengths.
Like an actual ocean has massive rolling swells and tiny little surface ripples at the same time.
Exactly like an ocean. Now imagine you put two solid walls into that ocean and you put them very, very close together. The massive swells, the really long waves, they literally cannot fit into the gap between the walls. They are geometrically excluded from existing in that specific space.
It's like trying to park a massive semi-truck in a tiny compact car parking spot. It just physically doesn't fit, so it cannot exist in that space.
That is a perfect analogy. So inside the tiny gap between the plates, you fundamentally have fewer waves than you do in the vast space outside the gap, which means the energy density inside the gap is literally lower than the energy density outside the gap.
And nature absolutely hates an imbalance.
Correct. So the higher energy pressure from the outside waves literally pushes the two plates together to close the gap. But here is the massive world-altering takeaway from this experiment. The geometry, the physical gap dictated the energy.
Wait, so the boundary conditions actually determined what waves were allowed to exist, which determined the energy state of the vacuum itself.
Yes. So the source is arguing that this isn't just some weird, obscure party trick you do with metal plates in a lab. This is fundamentally how the entire universe works at every level.
Wow. So gravity is a geometric constraint. An atom is a geometric constraint. A biological cell is a constraint.
Exactly. The source argues that Einstein's E equals mc squared is only perfectly true when there are absolutely no walls, no boundaries, no constraints. But since we actually live in a physical universe filled with gravity, matter, and boundaries, we are always, in a sense, living between the plates. We are always subject to that Chai-T topology factor.
This completely circles back to the very beginning of our conversation, doesn't it? We started out by saying time isn't an empty container. It's a specific geometry. Now we're saying fundamental energy isn't a raw substance. It's determined by geometry.
Yes, and we said humans aren't just biological accidents. We are a unique structural anomaly operating by new rules.
So let's try to really synthesize all of this. Moving into section 4, what exactly is the ultimate ground of reality here? Because it seems like all three of these highly complex sources are fundamentally fighting the exact same enemy.
They absolutely are. They are all fiercely fighting what philosophers call brute materialism.
Right.
Which is the depressing idea that the universe is really just a bunch of random, meaningless stuff floating around in a dark void, randomly bumping into each other until things happen.
The many-world source is fighting the idea that reality is just this random, infinite explosion of branches. The evolution source is fighting the idea that the human mind is just a random accumulation of biological complexity. And the physics source is fighting the idea that energy is just this random juice that powers the universe independent of form.
Right. Instead of random stuff, they are all independently arguing for a relational, structural reality. Meaning, things only truly exist in relation to the constraints placed upon them.
To exist is to participate in the structure.
Exactly. In the many worlds critique, the other branches aren't real precisely because they don't relate to us causally. In the evolution critique, the human mind is uniquely real because it relates to an external symbolic structure, not just its own internal biological hardware. And in the physics paper, energy is realized because it relates directly to a geometric boundary.
It really is all about the boundaries. The constraints are what actively create the meaning. Without the constraint, there's no form. There's just infinite noise.
Think about a guitar string. If you don't constrain a string, if you don't pin it tightly down at both ends, it can't ever make music. If you just strum a loose string, it just flops around, it's useless. You fundamentally need the tension. You need the boundary at the bridge and the nut to create a specific, beautiful note.
That is an absolutely perfect analogy. The universe itself is like a string under immense tension. The constraint allows the music to exist.
And this leads us to the metaphysical turn that's mentioned near the end of the sources. Because if invariance is the ultimate rule of the universe, if the structure is the main thing holding it all together, then what is the ultimate invariant? What is the foundation?
The source gets a bit philosophical here and calls it the null invariant.
The null invariant.
Yeah, the null invariant. They define it as the ultimate condition that makes any physical manifestation possible in the first place. And they actually draw a really fascinating parallel to the ancient concept of logos.
Logos, like the Greek philosophical concept of the word or the underlying logic of the cosmos.
Exactly. But not just literal words like you and I are speaking right now. Logos understood as the foundational underlying code of reality. The source explicitly says, this isn't photon theology. They aren't saying we should start worshiping light particles. They're trying to identify the absolute condition of manifestation.
Oh, I like how they frame that. Like, light allows you to see things, but you don't spend your time looking directly at the light. You look through the light to see the world.
Right. So the structure we've been talking about this entire hour, this deeply woven invariant structure of space-time and energy and mind, is the logos. It is the framework that lets the universe exist as a coherent thing rather than just chaos.
It's the ground, the steady background against which all the figures of our lives appear.
This is an incredibly heavy deep dive, I have to say. My brain is definitely getting a workout. But it's also incredibly satisfying. It feels like we've done some serious spring cleaning on our worldview. We threw out the messy infinite multiverse. We threw out the cynical humans are just bald apes argument. And we threw out the energy is just magic substance idea.
And what we are left with after throwing all that out is something really elegant, something intentional.
Let's quickly summarize the final major takeaways for everyone still listening.
Okay, let's bring it home. 3 main points. Point 1. The universe does not branch. It is one single invariant structure. You aren't lost in some terrifying library of infinite random lives. You are one specific, meaningful thread in one coherent tapestry.
Love that. Point 2. Humans represent a true discontinuity in nature. We aren't just really smart monkeys. We represent a completely new structural layer of meaning. We essentially brought symbolic software into a purely hardware-driven world.
Yes. And point 3. Energy is fundamentally written by geometry. The physical constraints and boundaries of your reality actually determine the kind of power you have access to.
Constraints determine the power. That is honestly a life quote right there. I might write that on my whiteboard.
It really is profound. Because human nature, we tend to hate constraints. We naturally want total, uninhibited freedom in everything. But the deep physics tells us a different story. It tells us that without the constraint, there is simply no energy. Without the firm boundary, there is no physical form. You need the resistance to generate the power.
And the source had that really beautiful, almost poetic line about time at the very end. Let me see if I can remember it. It said, "We are threads reading a text that was always already complete."
We are threads reading a text that was always already complete. Wow.
That is the exact thought I want to leave everyone with today. If the physical structure of reality is truly invariant, if the space-time block is already cast, and the book is essentially already written, then your movement through time isn't about frantically trying to go somewhere new. It's not about anxiously wondering which parallel branch you're currently stuck on. It's simply about reading the specific line that defines who you are.
The book is written, the structure is set, but you still have the massive responsibility of reading it with absolute attention.
Exactly. You still have to experience it. So the real question is, how carefully are you reading your page?
That is the perfect place to leave it. Thank you all for joining us on this massive deep dive into the underlying structure of absolutely everything. It has been quite a trip.
Always a pleasure to be here.
We will see you all next time. Keep reading your page.